So since there aren't any questions, this is an extremely simple example. I'm going to give an example that is more like what you would see in practice in just a minute. But in the slides, I wanted to do something that was really, really simple. So I could show you first how to do it in a very simple context, and then we'll get to something that's more like real life in just a second. So we will be indexing using position here for in a data frame, and this would work the same way for a matrix as well. So it doesn't matter if this is a data frame or a matrix. Very similar to what we saw with vectors. Each individual value in this object, which in this case is a data frame that we've created, has a position. So you can think of it kind of as Excel. You know, the first cell has position 1, 1, so column 1, value 1. It's the same here. So these are actually the variable names, so those won't be included in the indexing unless you explicitly tell R to do it that way. So this is position 1, 1. So Austin is in column 1, row 1. Going from there, in rainfall, this 1 value is in column 1, row 2. So on and so forth. So if you go back down to Dallas, that would be column 1, row 4. So how do you use indexing with this information? So based on this position, we can then pull out individual values or a series of values, which I'll show after this. So we have our rainfall data frame, and then just as we did with vectors, we have brackets after that. The first value is always the row number. The second column is always the column number. So it will always use, unless it's a vector and has one dimension, it will always separate these values by a comma. So this, in a very simple sense, is the structure for indexing. There's a lot more complexity to it that I'll show a little bit later, that you can use this and it's more flexible to do other things with this indexing. It won't, but this is always the basic structure of any index that has, that is not a list. So a matrix or a data frame, will look like this. So this is my example of rainfall data frame. So we can go over here. I am pulling the third row, second column. So when I do that, it returns 0.5. So again, third row, second column. So that is why this value is returned. So just to build on this a little bit more, it is also possible when you use indexing to return all of a one row or all of one column, but it does follow the same structure. So to pull a full column, leave the row number blank. This is a little different as well than Python. Python, you'll see that a colon here to show that it wants the entire column. But in this case, in R, the syntax, you have to leave it blank. Keep in mind, I put a space here just to show explicitly that this is empty, but you do not need a space there. You just put nothing before the column, before the column number. Then you have a comma. So this will pull every row in the second column. So when we do that, it's going to, I will show what it returns in R. So we just went over this. We can go into, I believe this is the practice solutions. So, and here is the Boolean vector that we showed. So in order to do, and we create this, if you want more of a review on this, one of my videos are up. I think actually this video is already posted. So it will be in the matrices, the data types, and structures section. So we have our rainfall vector. We created this with showing here. And then we're going to create a data frame with that value, with the vector value. This is to avoid using another file for you to upload, because this is actually dummy data. It's not real. because if I wanted to do very simple so far, and I'm making the rainfall city a character variable. So we went through that, and we can then open this up. We can see that this looks exactly the same as I had in the slides. So for when we're using this example, I'm just going to print this for reference, and I'm going to move up. So the value here is what I showed you before. When we take that rainfall data frame, we're doing the third row, second column. It returns 0.5. And then this is actually a factor variable here. I would like to show you what this looks like when it's not a factor, because that's going to be the most common thing. Just because of how I created this up here, it changes everything to a factor. If you need more of a review on what I'm doing right at this moment, you can go to the data types and structures video online. So we have our rainfall data frame, rainfall. So you can see now that this is a factor variable. And remember, when you have a number that is a factor variable, you always want to put as character first and then wrap it in as numeric. So now we have this here, we have our numbers. So I think that that is the easiest way to see this. So we have that rainfall data frame, it is returning 0.5. But even when it was a factor, it still returned that value. It just also listed the levels as well. In reality, it does it the same way, but this looks a little more simple, and this is what you would usually use in practice. So we will go over this in a second, but I want to also show that if we're going to pull the whole second column, so we keep it blank here, we then, as you can see here, let me scroll up, this took the whole rainfall column, every row in the rainfall column. So again, this space means every row. Similarly, you can take the entire third row and pull every column. So remember, this is the row position. So in this case, I'm telling it to pull the third row, all columns. So then it is pulling, as we see, the third row here, Houston. I just want to demonstrate that getting rid of the space does not change the answer at all. So space or no, depending how you like to read it. I do like putting a space there because it's explicit and it helps me see and remember things. So here was another, we'll go over that example in just a second, but coming back in. So it looks like that I did not put this in the slides, but just as we can pull multiple values in a vector, we can pull multiple values in a data frame. So this here, as we saw with the vector, translates to row 2, 3, and 4. So basically everything inclusive of 2 and 4 and everything in between. So the next one it's asking for is column 1 through 2. In this particular example, you could have left this blank and it will return the same thing. But when we do this in practice, there's usually more columns than just 2. But to just show this, it took row 2 through 4, and then comma, and then it pulled column 1 and 2. Again, we're going to have another example that's more like a real life in just a little bit. So are there any questions about that before I move on to the next values? All right. And I'll monitor the chat, so feel free to ask questions in there as well. So that goes into how you would index a data frame. Another very simple example, I had mentioned earlier that you can index based on values as well. So what we're seeing here, this would be better used in a larger data frame, but it can be used in a small one as well, and that's what I'm going to show the example of. But that rainfall data frame, we say we want to pull every row where city equaled Austin. So remember, this is the row value. So it's specifying that in that row, so it is referring to the city column, and we are specifying the column here because then it can tell us what rows to pull. So rainfall data frame city, where city equals Austin, it's going to pull that entire every row for that value, every row that has this value, and then it has the space, so it's going to pull all columns where rainfall df city equals Austin. Remember here, I went over this, and I believe at least the last class, if not the last two, we are using equals here. So in this case, we are putting that rainfall data frame city. If we had equals here, it would assign all the values in this particular rainfall data frame as Austin. So it would actually modify our data frame, because remember, this will tell you true or false, is something true or false, does it match, basically. Whereas one equal sign is the same thing as an assignment operator, which is the same thing as a caret and a hyphen. You'll also see this is a little different here. Just you can think of it in this way. So this rainfall.df, we have to list it here, but we also have to inside say that we're talking about that rainfall data frame, and that we're referring to the city column. This is actually equivalent to this. So hopefully that gives you some information about indexing, and that it can be done, in multiple ways. Also, I've gone over this in previous classes. The subset function or the filter function can also do what I'm showing here. So the filter function is in dplyr, subset is in base R. So we are seeing this, that it will be the same. So we are pulling everything from rainfall data frame, where rainfall data frame equals Austin, city equals Austin. Why do we have to explicitly say that it is in rainfall df city? So why do we have to explicitly say if it's in this data frame when we have rainfall data frame before it already? The reason is, and we saw this with vectors, with our Boolean vector that we created, you can use different objects or objects outside of rainfall df in order to specify indexes. We're going to show an example of this in a minute, but you could use something other than rainfall data frame to then subset this vector. This data frame. So you could, for instance, use a vector in this case to subset, which I will show you in a minute. Are there any questions about this or anything I've covered so far?
Yeah, so you mentioned like using dplyr or base R, subset or filter. And I may have missed it. I'm assuming that this is all base R that you're showing us
Yes.
right now. Yeah.
Yes. Indexing it's not inside a package. Yes. No. Is that your only question so far?
I mean, I can ask more if you want.
I mean, if you want to, I would like that.
I'm gonna.
Yeah.
I'm very curious as to how you put how you subset using other vectors.
Yep, that's the next thing I'm going over.
Yeah. So I'm probably gonna hold my questions till then because I got a lot.
Okay.
I think it's gonna be very useful. But how
Yes.
how often do you just hard code these filters on a specific data frame for a vector?
I usually would use this filter function for this, but there are other uses for indexing that I use indexing for, that I will show later. One of them, I'll just scroll down to just kind of give a preview. So we're talking about missing values here. So I, in a lot of cases, will use indexing to change column names. That rename function works well for that too. So you could use that. This is my main use. So with indexing, it's really easy to replace values. This is a good example where this would be somewhat difficult to do just through like dplyr. It's a lot easier to do it this way. So this, in this case, and we'll go over this in more detail, it's replacing anything where Virgin Islands equals US here to US Virgin Islands. For instance, say something that you didn't want these parentheses in here because it might screw something up down the line. You could change it here. So that is something that I always, a lot of the times do. Also, you can replace missing values with this. So I always use indexing for that. There are other functions, but it's like one to remember and that I don't really want to go through. Like, I think it's a little bit more complex to do it out with the NA dplyr function, or it's simple, but I already know how to index and I can do it quickly, I guess. So I also use this very heavily in looping. So the indexes for the data frames. So I, in general, say don't do looping unless you have to, or unless your data set's extremely small and the performance issues won't make a big difference. But I use indexing both to loop through rows and to loop through data frames. In particular, this is what there's something very similar that I would use in a loop. The next intermediate class, I believe it's the first or second one after the Christmas break. It's pretty soon. We'll show more about that. But say you want to loop through every values of cities within a data frame, for instance. So in a real case scenario, you might have cities listed multiple times, that more than likely. So you would have data on many cities, but also more than one city within that. When you create a loop, you can loop through all the different cities and specify that, and then basically subset with indexing inside of that loop to pull every value that equals Austin, and then you can do a lot of functions on it, and then you can spit out the results. So you would spit out the results for Austin, then San Antonio. So this is the first thing you would do when you were inside of the loop. Again, you could do this with the filter function, but I never seen it done that way. I think it's a preference thing. It's usually done this way. I always see indexing used in that case. And that's also how you would, so say you wanted to loop through every row, you would put like you would set in looping 1 to the number of rows in your data frame. And then you would do something like this. You would set I to be 1 by 1, pull through each individual row, and then you would put an I here instead. And then you would be able to loop through row by row instead. That's a very high level summary because there's a lot to it, but I've never seen a loop written without indexing. So hopefully that answers your question, and that we'll have a whole lot of information on that in the next intermediate class. So this I've already shown. Again, this is going to pull rows 2 through 4 and columns 1 and 2. But that would also be equivalent to keeping this blank. It's just a very small example to show you that the rows go here, the columns go here, and the colon says to have each individual value here. So I'm going to go in real quick. So we have that rainfall here. I believe I do go over this a little bit later. So this is how you can do based on values, for instance. So in this case, I want to pull the rainfall that is above 0.5. So just as I did before with the fruit prices, I'm going to create a Boolean vector. This again can be done in one step. but I want to show kind of step by step without adding a bunch of things in together at one time. So we create this Boolean data for, and this I probably the reason I said data frame is we're about to subset a data frame. So we have this Boolean data frame. You can call this anything that you want, and you're seeing that here, based on our rainfall. I'm going to print it real quick. So it is telling us that in rainfall, these values are above 0.5. So that's above 0.5. That, and it's greater than, not greater than or equals to. Notice that is above 0.5. This is actually equal to 0.5. So it is, when you have the greater than there, it's not going to include 0.5. And then we'd have 0 here. So in this case, we can then use this in order to subset by value. So we are creating rainfall small. So we are indexing the rainfall data frame. We're pulling every row where rainfall is greater than 0.5, and we are pulling all columns for those rows. Just to show you that this is done, can be done in one step, so can be done in one step. It would look similar to this. So rainfall, and I'll put test just because we're showing how this can be done, and it's actually going to produce the same results. So instead of this, we could do, and then remember you have to put the column in here. So rainfall greater than 0.5. I didn't use greater than or equals to, comma, and then I'm leaving it blank. So now if we print rainfall test, we will see that this returns 1.0. So everything where it's greater than 0.5. So, and we can also print rainfall small. Oh, sorry, I must not have. It has the same values here. So in practice, you would do it in one step for the most part, but I wanted to show kind of how you can use another value in order to subset here, or another data frame or vector in order to do this. So that is how we would use this particular subsetting. I believe that I talk a lot more about this down here. This is the main replacing values. I always use indexing for this. And there are a lot of other use cases for it, that there's so many of them. It tends to be useful, and it's like even programming languages that aren't data analysis programming languages usually have indexes in some way. So that is hopefully answers your question on how you can use values in order to subset as well.